All right, today we're going to cover some more types of solving proportions problems, but before we do, we better warm up with what I call a baby solving proportion problem, the kind that you've kind of got your feet wet with the last couple days. We'll call this problem number 1, and let's solve this quote-unquote baby proportion. R over 8 equals 25 over 40. You've done a couple of these the last couple days, and didn't we say that cross products are equal? So our job is to cross multiply and set up a new equation. So 40 times R is 40R. And on the other side of the equation, I have 8 times 25. We are cross multiplying. With a proportion, this is the one time when we really do cross multiply. So 8 times 25 is 200. So now I have 40R equals 200. And basic solving equations, to move the 40 over, I do an opposite operation. The opposite of multiplying by 40 is dividing by 40. On the left side, 40 divided by 40 is 1, so those go away. And I just have my R by itself. R equals 5. That's what we've been doing the last couple days, what I would call a baby proportion. So now we have to I guess, grow up a little bit more and do ones that have a little bit more to them, like number 2. X minus 2 over 14 equals 2 over 7. And right away we notice something different. If you notice, this thing right here is a little bit different. Instead of an x, it's an x minus 2. So when I still cross multiply, but we need to be more careful. When I cross multiply here, it's 7 times the quantity x minus 2, which means I will have to use the distributive property in a minute. All right? And that will be equal to 14 times 2 on the other side. And that's the main difference. All right? So let's do distributive property here on the left side. 7 times x is 7x, minus 7 times 2 is 14, and that's equal to 28. And then it's a very simple equation to solve after that. We add 14 to both sides, add 14, 7x equals 42, divide both sides by 7, and x equals 6. All right? Now, our next problem, I would like for you to try one on your own. If you're watching this online, pause the video and try this problem on your own. The next one is x plus 4 over 5 equals 3/8. Same type of problem. I'm going to give you a hint when you try this on your own. Your answer is going to be a fraction. So pause the video if you're watching it online and try it on your own. All right, let's see how you did. When we cross multiply, I have 8 times the quantity x plus 4, and that will be equal to 5 times 3. Make sure you are actually cross multiplying. Sometimes people don't pay attention, and instead of cross multiplying, they do something like this. They do 5 times 8, or they do 5 times the top, or something like that. make sure you are cross multiplying diagonally. All right? So finishing this up, I have 8x plus 32, because I have to use distributive property, equals 15. Should be straightforward from that point on. Subtract 32. 8x equals negative 17. And you divide both sides by 8 to get our answer, which is negative 17 over 8. All right? Now, one other type of solving proportion problem we could get is one like this. Let's see, this is problem number 4. And on this one, there's another extension that you've got to catch. 9a minus 3 over 9 equals 5a plus 5 over 3. So once again, we cross multiply. And if you notice something, on both sides of the equation, I've got some extra stuff. So when I cross multiply 3 times 9a minus 3, I have to use distributive property, equals, when I do 9 times 5a plus 5, I have to use distributive property. So I'm using distributive property on both sides. You'll have some like this tonight. So I do distributive property, and I have 27a minus 9 on the left side. I do distributive property on the right side as well, and I have 45a plus 45. This is a good review of solving equations for us, because now I've got the situation where I've got an a on both sides. So I have to get the a terms together using algebra steps. I think there's several ways I could go with this, but I like to get my a terms together first. I'm going to subtract 27a from both sides. Make sure you're lining it up under the a terms. Don't put the 27a on the left here and then put it over here on this side. Okay, it's got to be under the a terms. So my equation now, those go away, and I have negative 9 equals 18a plus 45, and it should be pretty easy to finish solving. Our next logical step would be to subtract 45 from both sides. And on this side, those go away. I'm left with an 18a over here. On the left side, negative 9 minus 45 is negative 54, because my hole gets deeper. And then I divide both sides by 18 to finish. 18's cancel. Final answer is negative 3. One last thing, proportions are super useful in the real world. Someday you may have to paint some rooms in your house. Believe it or not, you use a little bit of algebra when you have to do that. You know why? You have to know how much paint to buy. If you buy too much paint, you're stuck with it, and paint is expensive. So let's say that 2 gallons of paint covers 830 square feet. All right, you purchase 2 gallons of paint, and it covers 830 square feet, but that's not all that you have to paint. How many gallons of paint total are needed for 1,700 square feet? You're going to Lowe's. You've painted 830 square feet with 2 gallons, and you need more paint. All right? And you've already bought 2, and you don't want to waste a bunch of money, because once they, I don't know if you knew this, but once they mix up paint at Lowe's or Home Depot, once they mix it up with the color you want, you can't take it back. So you're stuck with it, and paint is expensive. So what do we do here? Well, a proportion is a great way to do it. We set up a blank proportion. And the main thing with proportion problems that deal with word problems or real life stuff is if I compare gallons, I'll abbreviate gallons to square feet on the left, then I have to compare gallons to square feet on the right. That's the main rule. Plugging the numbers in should be pretty easy once you follow that rule. So here we go. Gallons to feet. Well, 2 gallons covers 830. 2 gallons covers 830 square feet. Okay? So on the right side, I'm asking how many gallons. Gallons are on the top. That side will be an X. That's the one I'm looking for. How many gallons are needed for 1,700 feet? So the 1,700 goes there. And now it's actually just a baby proportion that we started the day with. I cross multiply 830x equals 3,400. That's 2 times 1,700. Divide both sides by 830. And that decimal value, this would be a good calculator problem. I'm grabbing my calculator to do this problem. 3,400 divided by 830 is 4.1 gallons. $4.1 gallons total to do the job. If you had already purchased 2, now here's a good thinking point. If it's going to take 4.1 gallons, how many total gallons will I have to buy? And I don't mean, I'm talking total gallons. I know we've already bought 2. But if I need 4.1 gallons, 4 gallons won't do the job, will it? Unfortunately, I'm going to have to buy 5 gallons total. If I've already bought 2, then I'd have to buy 3 more. All right? Because it's going to take 4.1 to finish the job, unfortunately. Maybe you could buy a quart of paint instead of a gallon of paint. That's possible. All right? And we will stop there for today.